Hi, this is Ms. Paflin, and I'm going to go over the Unit 6 practice test for Algebra 1. Number 1 says, explain why each histogram below would not be appropriate for the data provided. So just looking at a quick glance, I can see right away that the intervals are the same, 15 to 24, 25 to 34, and so on. They're counting by 10. But since they have consecutive numbers, if we're going from 24 to 25, these bars should be touching each other. So the fact that they're not is the incorrect. There are spaces between the bars. We want them to be touching each other because they're showing consecutive data. There should not be any spaces. I also can tell right away, because these intervals are the same, that these bars should all be the same width. If they are both, all of them are representing data in sets of 10 students, they need to be the same width. The histogram bars are not the same width. This one is going by different intervals from 15 to 19, 20 to 29, 30 to 39. We want them all to be the same, because from 15 to 19, that's 5 students, but then 20 to 29, that's 10 students. So we can't have that because that's a misrepresentation of the data. So the intervals for students do not have the same amount in each. Number 2, according to the histogram data shown, which percentage of cities had an annual rainfall of at least 28 inches? So if I have this line is at 28 right here, if it's saying at least 28, then everything that's 28 and greater than 28. So all of these bars after the 28 inches would be at least 28 inches. So I have to count how many for each bar. I'm going to write it above. This one's 2, 4, 6, 7, and 3. So I want to add these all up. 2 plus 4 plus 6 plus 7 plus 3. And then that's just my numerator. To find percentage, you want to divide it by the total annual rainfall of the cities. So I also then need to account for this between 26 and 28. There were 3 cities. So now I'm going to add all of those together. 3 plus 2 plus 4 plus 6 plus 7 plus 3. All right, when I add the numerator, that is 22 cities, and the denominator is 25. So 22 cities total have at least 28 inches of rainfall, and there are 25 cities total in this data set. So to find percentage, we divide those together. We get 0.88. And then to find the percentage, you would multiply by 100 or move the decimal 2 to the right. That's 88% of the cities have at least 28 inches. Number 3, according to the histogram data shown, how many cities had less than 36 inches of annual rainfall? All right, so now I'm going to go to my line at 36. So less than 36 would be all of these beneath. So if I know that there's a total of 25 cities and only 3 have more than 36, I know I can just subtract 3 from that, and there are 22 cities that have less than 36 inches of rainfall. Number 4. The following data shows meal option prices in dollars at Bob's Burgers. Create a histogram for the data. So before I even graph it, I want to make a t-chart to find the frequency. So I'm going to have the meal price here on my x-axis, which I will also label on the graph, meal option prices. And then the frequency. And that would be your y-axis. Now I have to think of what intervals I want to do with my data. So I see my numbers go from 6 to 17. So I could start with 6 or like start with 5 through 9, or you can always start with 0, depending on your data if you want to do a broken graph or not. This one, it's close to 0, so I'm just going to start with 0 through 4. I'm going to do intervals of 5, and then 5 to 9, 10 to 14, and 15 through 19. So from 0 to 4, I know there's 0 frequency. Then 5 to 9, I have 1, 2, 3, 4, 5. 10 to 14, 1, 2, 3. And then 15 to 19, 1, 2, 3, 4, 5, 6, 7. You don't want your intervals to interlap. Like we wouldn't want to do 0 to 5 and then 5 to 9, because 5 would be in both of those data intervals. So make sure you never have numbers that are the same in two different sections. All right, then I would go to my graph. I'm going to do 2 bars for each interval, 0 to 4, 5 to 9, 10 to 14, and 15 to 19. Then I need to label my frequency. It goes from 0 to 7, so counting by ones would be good. All right, then I can add my bars. So there was 0 for 0 to 4. 5 to 9, there was a frequency of 5. So 5 different meal options are in that price range of $5 to $9. There are 3 meal options between $10 and $14. And there are 7 meal options between $15 through $19. Number 5. The histogram below shows the scores of Mrs. Smith's first block class at Red Rock Middle School. If a 61 is the lowest score a student can earn a passing grade, how many students earned a passing grade? Looking at the data, all of the students scored at least a passing grade, so now we just have to add up how many students each bar represents. So this one's at 3, 5, 7, 6, and 4. So we want to add those all together. 3 plus 5 plus 7 plus 6 plus 4. That gives us 25 students had at least a passing score. The dot plot shows scores from an English quiz. 6, use the dot plot to complete the frequency table. So we just want to count up how many dots for each score. So there were no dots for 0 or for 10, so that would be a frequency of 0. 20, there are 3 dots. So 3 students got a 20 on the English quiz. 30, 0 students. 40, 2, 51, 60, there's 1, 2, 3, 4, 5. 70, 2 students got 70, 4 students got an 80, 1 student 90, and 2 students 100. 7, what is the median quiz score? For me, I like to list out all of my numbers from least to greatest. So you want to always do it from least to greatest when you're finding the medians in the 5-number summaries. So there were 0 at 10, so I don't even need to write 10. 3 students had 20, so I'm going to write 3 20s. There were 0 that had 30, so I don't need to write that. 2 students had 40, 1 50, 5 60s, 1 2 3 4 5, 2 70s, 4 80s, 1 90, and 2 100s. All right, to find the median of the data, I need to get the very middle number. So I believe there are 20 different scores, 20 student scores here, so I need to count 10 on each side. 1 2 3 4 5 6 7 8 9 10. I'm going to use a different color. 1 2 3 4 5 6 7 8 9 10. When you have an even number of data, you will end up being in between the data points. You want to find the average of those two values, which is 60. So I would do 60 plus 60 divided by 2. 120 divided by 2 equals 60. If they're the same number, your average or mean is going to be the same number as well. But I'm just showing you this in case they're different numbers. You want to find the average by adding them together and dividing by 2. So that means our median quiz score was 60. What is the average mean quiz score? So then I have to add up all of these scores. 20 plus 20 plus 20 plus 40 plus 40 plus 50 plus 60 and so on. And then I have to divide it by the total scores. So a way I like to do it, so if you get to choose, you can just add these all up, type them in your calculator, add them up. Or another kind of, in my opinion, easier way is I go over and I just multiply each score by the frequency. Like I know there were 3 students that got 20, so I do 20 times 3, and I get 60. 40 times 2, 80. 50 times 1, 50. 60 times 5, 300. 70 times 2, 140. 80 times 4, 320. 90 times 1 is 90, and 100 times 2 is 200. And then I add all of these together. To me, it just is a little less work than typing in all the individual numbers, but it's up to you. When you add all of these together, then you get 1,240, and then you divide it by how many numbers there are. There are 20 student scores here, and you would get 62 for your average quiz score. What is the range of quiz scores? Your range is found by taking your highest score, which was 100, and subtracting it by your lowest score, which would be 20. Now, you would think, well, why wouldn't we do 100 minus 10? Well, there were 0 kids that got a 10, so it's only the scores that actually have a frequency number. So that would be 100 minus 20, which equals 80. So there was a range of 80 points or percentages between the English quiz scores. Data was collected on how many junk emails 3 office employees received each day for 20 days. Find the mean, median, and range of Anders' data, then determine if the mean or median is the best representation of the data. So again, I like to list my numbers from least to greatest to find the median. So I know that there was 1 junk mail email for 1 day, 2 dots for 2, so I put 2 2s, 2 3s, there were no 4s. Then for 5s, there was 1 2 3 4 5 6, 1 2 3 4 5 6. For 6, 1 2 3 4, 1 2 3 4, and for 7, 1 2 3 4 5. 1 2 3 4 5. All right, then to find my mean, now we're given 20 days. So again, I know there's going to be 10 on each side, finding the median. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just to double check that I wrote all the numbers out, I'm going to go on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 5 and 5, our median is going to be the exact same number. Median is 5. Oops, not spelling that correctly. Median equals 5. All right, then to find the mean, we want to add all of these numbers together and divide by the 20 numbers. So when you add them all together, it would be 100 divided by 20, which equals 5. So our median and mean are the same number. And then a range, again, is the highest subtracting the lowest data values that actually have frequencies. So our highest number with frequencies is 7, our lowest is 1. So the range is 7 minus 1, which equals 6. It also asks to determine if the mean or median is the best representation. Well, in this case, they're the same. So mean or median is a good representation. For number 11, find the mean, median, and range of Joseph's, this should be Joseph, not Marcus, data, then determine if the mean or median is the best representation of the data. So again, you could list all the numbers out. Another way to do it, which I will show you right now, if you don't want to list it all out and you're able to keep track this way, you could also just find the median by just like going and crossing out 10 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I go from the other direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know it's going to be in the middle here between these green and blue points of 4. So I know my median is 4. But if that's something that is confusing to you, then definitely list out those numbers like I did up here on number 10. All right, then the mean, again, we want to add up all those values. So another method to show you, like I was doing with the table on the previous page, you can multiply. Like if I know that there were, for the junk emails, there were 1, 2, 3, 4 days where he received 2 junk emails, I would do 4 times 2, which is 8. And then there were 1, 2, 3, 4 days where he received 3 junk emails, so that's a total of 12. 2, 3, 4, 5. 5 times 4 is 20. 1, 2, 3, 4. 5 times 4 is 20. And 6 times 2 is 12. And then I know there was 20 total, so then I can just add these together. And that would give you 82 divided by 20. Oh, I just realized I missed this 10. Be careful with those outliers. Those are sometimes easy to miss. And then let me make sure. Now I'm questioning if I added those correctly. So if I do 8 plus 12 plus 20 plus 20 plus 12 plus 10, 82. Okay, so I did have the right number on my key. 82 divided by 20. And that would give you 4.1. So the mean equals 4.1. And then the range, again, the highest value with a frequency would be 10. The lowest value is 2. 10 minus 2 equals 8. And in this case, even though the median and mean are very close to each other, I would still say the median is a better representation of the data, because when there's an outlier, that's always going to affect the mean. So medians are always better when there's an outlier. Median is better representation due to the outlier. All right, same thing for Marcus on number 12, finding all these same data points. So again, counting 10 on each side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And going from the other direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's between 7 and 7, so the median is 7. Again, I'm just going to multiply how many dots in each. So 2 times 1 is 2, 3 times 1 is 3, 5, 6 times 3 is 18, 7 times 1, 2, 3, 4, 5, 6 is 42, 8 times 1, 2, 3, 4, 5, 40, plus 9, plus 20, divide by 20. All right, when you add them all together, 139 divided by 20, which is 6.25. Or sorry, 6.95. Range, highest amount of emails was 10, minus the lowest was 2. 10 minus 2 equals 8. And for this, which is a better representation, again, our mean and median is very close. So, I mean, I would accept either answer in this case because they are so close and we don't really have outlier. I mean, we kind of, these 2 and 3s are a little bit further from the rest of the data, but not too much. There's not really outliers on this. So I would accept either, both mean and median are good representations. A group of people were asked if they drink soda and if they prefer salty or sweet foods. The two-way frequency table shows the results of the survey. So first thing is we have to complete the table. So you're given some of the data, but not all of it. So we kind of just have to go and fill in what we can. So like I know if there's 105 sweet and 135, so for the sweet, the ones that drink soda is 105 and the non-soda drinkers 135. I'm going to add these together to get the total. Plus 135, 240. So I know the total across is 240. Then I can go down and get these 260 plus 240, 500. If I know total of 290 do not drink soda and 135 sweet, then I can subtract 290 minus 135. So that would mean 155 like salty foods. Again, total of salty is 260 and the ones that don't drink soda is 155. So I could subtract 260 minus 155. So I know 105 drink sodas. Now I can fill in the total here. 105 plus 105 is 210. Now I have all of my sections filled in. 14, construct a table that shows the joint, should be here, relative frequencies and the marginal relative frequencies for the data. If necessary, round to nearest hundredths. So for these, you want to divide how many in each section by the total, 500. So 105 divided by 500. It's going to give you a decimal, but I always convert these frequencies to percentage. So I multiply them by 100. That's 21%. Does not drink soda, but likes salty food. 155 divided by the total 500. 155 divided by 500, 0.31 times 131%. Total 260 divided by 500. 52. Another way is I can just visually see that's 52%. If I move that decimal 2 to the right, that's 52%. And then always double check your work. These numbers should add up together. 21 plus 31 is 52. So make sure you check those to make sure your math was correct, because sometimes we make mistakes and we type it wrong in the calculator. All right, sweet that drinks soda was 105 divided by 500. So I already found that with the salty foods. That one was 21% also. The total is 210 divided by 500. And remember, these totals of drink soda, that's 21 plus 21. That should be 42%, but I'm just going to double check. 210 divided by 500, 42%. So that works there. Then we have 135 divided by 500. It's going to give you 27%. 290 divided by 500, 58%. And then our total for our sweet across here is 240 divided by 500, 48%. And then your totals should add up to 100%, because right here you're going to have 500 divided by 500, which is 100%. Make sure your totals, your marginal frequencies for the row and column add up. So like 42 plus 58, that equals 100. So these should add up to 100, and then these going down. 52 plus 48 is also 100. What percentage, what is the percentage of soda drinkers who prefer sweet foods? So I go to soda drinkers who prefer sweet, that's 21%. Oh, this though, I'm sorry, I just realized this is saying what percentage of the soda drinkers. See, even I just made that mistake. We have to be really careful of the wording, because this is actually asking of just the soda drinkers. So let me go back and see how many total soda drinkers there are. That's 210 soda drinkers total. That's my denominator. And then how many of those prefer sweet foods? 105 of the 210 soda drinkers. So that would be 0.5, which equals 50% of soda drinkers prefer sweet foods. 16, is it more likely that a non-soda drinker will like salty foods, or that a soda drinker will like sweet foods? So that one, if I go to my non-soda drinkers that like salty foods, that's 31%. And then my soda drinkers who like sweet foods is 21%. So it's more likely that a non-soda drinker at 31% will like salty foods. All right, I'm going to stop the video right now, and I will make another video for the rest of the packet.